Sorry. Okay, so you
there might be violence.
Okay. Hi, everybody. Thanks for coming. My name is Chris Woodfield. I'm with Twitter on the network engineering team. So just a quick informal show of hands. How many of the people right here work with load balancers on a regular basis? Okay, good number. So follow up, for those of you who haven't raised your hands, how many of you have them in your infrastructure but they're not managed by the network engineering team? Okay. Of those of you who haven't raised your hands yet, how many of you don't worry because you've got a script for that? Okay, if you raise your hand, I might want to talk to you afterwards. Okay. So anyway, again, thanks for coming. And I think we're here to discuss fundamentally ways in which we can, as network engineers, at this level of the stack, can help our customers' apps scale by either offloading or allowing for, just the fact that a VIP allows for wide horizontal scaling, and then you can go up or out from there. So a couple key questions. When we think about the problem space, there is a pretty wide array of strategies, options, and what that comes with that is that you do get a lot of customer confusion, and a lot of people, when they're first going into this, first building an infrastructure, you're kind of shooting in the dark. Do I want to do layer 7, layer 4, and we'll go over the various options, but you don't know how big you're going to be in 2 years or 3 years, and you're terrified of making the wrong choice now because you might have to undo it later. Because what worked when you were getting 1,000 page views an hour won't work when you're getting millions, obviously. That said, you might, on the other side, the large scale solutions just don't make sense at lower scales either. So you have to figure out a transition plan, and when you're going to start small, and at what point you're going to start getting larger and grow and change strategies as your application approaches internet scale. This slide deck is buzzword compliant. So there's a few base options in the current product offerings, both vendorware and open source. So we all know the appliances. There's several vendors here and many others. A10, F5, Big IP, NetScaler, Brocade, and it goes on and on. We're seeing more and more software come into the market space too. Most of the hardware vendors now offer software versions of their load balancing systems. Most of them are supplied as virtual images you can install on an ESXi or Zen server. You've got some other solutions. Riverbed sells a software suite. There was a company called LineRate that sold a load balancer app that installed on an ISO on bare hardware, no hypervisor required. I think F5 bought them a while back. And then we have open source solutions. I'm not aware of any appliance-based open source solutions. If they're out there, let me know. But certainly on the software side, there's LVS and Keep Alive D, which is at least partially in the Linux kernel, and then you have verse proxy solutions. Varnish is a big one, Mod Proxy, Squid, others. And the thing is, like, any one of these can make perfect sense for your particular problem, but there's just so many to choose from. Where do you even start to think about what you're going to be doing? And what you see is that as the number of options, you do have a number of basic styles. You've got the application proxy style, and then you have a couple NAT-based solutions. And we'll go over these one at a time just as a refresher. So layer 7 load balancing is essentially you're running an application proxy. Not 90% of the time the people doing this are doing HTTP, but it's obviously not limited to HTTP. SMTP, I've seen MySQL, I've seen DNS, any layer 7 application that you've got a box that receives the connections and then takes that payload and then forwards that query on to a server farm. If you want to do SSL offload, if you want to centralize that and take advantage of specialized hardware, you can do that at this layer too. You are going to run into more contention with resources. The boxes are simply doing more work than other solutions. Everybody supports it. Here's where most of your open source solutions live as well. And if you're using a CDN, you're already doing this. Just in a very specific narrow application space. Next we have layer 4 solutions, where your virtual IP, the box hosting your virtual IP, is basically running as a NAT TCP UDP router, a connection-based router. Here, your box isn't doing nearly as much as it is under layer 7, but you get no application intelligence. And that's your trade-off. Less resource intensive, but you're going to have to bring your own SSL. We can also do a trick called direct server return, which some people know about, but just as a refresher. This basically allows for the server that receives the connection after it gets forward from the load balancer to reply to the client directly. It effectively spoofs the source IP of the original VIP, sends a response directly, which bypasses the LB, and in most client-server traffic flows where most of your traffic is server to client, that saves a lot of resources. The trade-off is that your load balancer doesn't get to see both sides of the connection, which can bring some other issues as well. Again, most of the solutions most of the vendor solutions out there offer this. DSR implementations vary in the details I've found, and this is also where LVS plays well. Now, once you get to the point that you've got a single VIP, at some point you're going to have to spread out sideways too. You're going to have multiple endpoints for your service. Again, a whole bunch of different options. Where do you even start to think about it? DNS base is usually where people start with. That's the most obvious and easiest to implement, but you have to bring in failover situations, which means you can't just, you have to have something actively managing the IPs you hand out in response to failures. Geolocation comes in here. Other solutions you can have is active-active HA or clustering, where you can stripe either multiple VIPs or even the same VIP across multiple members of a high availability cluster. I've seen ECMP balancing, where you take a single IP and depend on upstream routers doing flow hashing to send all the packets for a particular TCP connection to the same box. That can then farm it out to the same server. And then and I've seen people do this with Anycast well, where they put, usually you see this for DNS, but I am seeing people doing this with TCP with varying levels of success as well. And all of these solutions fail over differently. There are vendor supplied solutions and, again, open source solutions out there in the field for a lot of this. And based on the one you pick, your mileage may vary. So we'll be discussing the pros and cons of some of these various approaches. The panel we have, again, I'm Chris Woodfield. I'm with the Twitter team. And let's go left to right to so the rest of the panelists can briefly introduce themselves.
Yeah, my name's Mike Thompson. I'm a senior product manager on the technical side of A10 Networks. I focus on cloud security and one of our lead OpenStack developers.
Jamie Dahl, Director of Network Operations at Yahoo.
Closer tonight.
I did push it a little bit closer. Jamie Dahl, Director of Operations at Yahoo. Also part-time load balancer engineer, and time permitting. Just mostly deal with trying to stay ahead of the scale of what our customers need, things like iOS 7 launch and the traffic that brought on, just trying to stay ahead of that growth curve as we ramp up our traffic.
I'm Leslie Carr. I'm a senior operations engineer at the Wikimedia Foundation. I'm sort of representing the open source and commodity hardware point of view.
I'm Sridhar Devarapalli. I'm part of the product management team for Citrix Systems. I focus on cloud orchestration, multi-tenant and software appliances for load balancing, as well as our emerging SDN strategy.
Great. Thanks, guys, again for coming. So from here, I'll just go to our discussion questions. Let's start with the first one, which I'll paraphrase. A lot of what you do at the LB layer really does depend on the application. And in what ways do your application and also your network designs inform and influence your load balancer designs, architecture, and scaling strategies at that point? Where can this help you, and what are the risks or rewards? The style, I think we can just start with going from left to right for each of the questions, and feel free to go back and forth if you like from there. So we'll start with Mike.
I think it's all about the application ultimately. These technologies are really there because they're solving business problems or allowing consumers to access resources in a way that actually makes sense. And so I think when it comes to design, I think any methodology that is based on a religious viewpoint inherently misses the point that it's all about efficiency, optimization, and really to the second portion of the question, it's really about the risk and reward. In certain environments such as Yahoo and Twitter and Facebook and other large environments, those have different needs than, let's say, the other 99% of the infrastructures out there. And so based off of what actually makes sense should really be the approach, whether it's ECMP, GSLB, just whatever systems you feel appropriate.
For what we do at Yahoo, obviously we have to deal with a lot of scale, a lot of high volume, but it actually gives us an opportunity to work with the application owners, engineers, and architects to really get an understanding of what they need. Obviously, when you are dealing with large scale, high traffic, keep it simple, stupid is the preferred method, but it doesn't always work. Sometimes you really do have to kind of think outside the box. So it just really gives as a network engineer, you really have to be able to kind of go both ways for both systems and networking to really be able to come up with the right solution for your end users and your customers.
So I find really interesting is when do you decide to do DSR and layer 2 versus layer 3 DSR? As many of us know, Yahoo has been huge in basically creating layer 3 DSR. So your network design is really important. If you have, as shown, like Facebook yesterday, everyone saw was running each top of rack with its own layer 2 domain, and layer 2 DSR would be very difficult because you'd have to have your load balancer have a virtual interface or be part of every single VLAN, and you don't want to necessarily have to administer that network-wise. Of course, layer 3 DSR then creates a lot more complexity at your router level because you have to be looking at QoS bits or however else you're going to be marking your VIPs. So I find that very interesting as well. DSR versus non-DSR. DSR has some advantages such as you get to you don't have to spoof your source IP and don't have to insert any other headers. For example, X4 is very common when you're doing HTTP load balancing. And it depends on what your needs are. As well, for scaling, DSR allows you to use a much less powerful load balancer for the amount of traffic you have, especially if you have a very heavy outbound application like most of us content providers.
I think load balancers have it's a unique kind of a network service where it needs both deep intelligence of the network as well as deep intelligence in the application. It's probably one of those rare network services that needs to be embedded deeply into both these realms. So it comes as no surprise when we think about how it how it's influenced by both the application stack as well as changes in network design. So for instance, as we think about the newer ways of architecting applications, there are emerging technologies or architectures such as service-oriented architectures that actually disaggregate and componentize application stack into distinct components that can run separately and take advantage of each other's availability and functionality. So that would directly influence the architecture for load balancing, because now the application is built in a distributed model that would sort of influence a distributed model for the load balancing also. Because remember, load balancing is actually closely follows the application's availability characteristics, basically. From a network standpoint, most recent trend has been that this classic three-tier architectures, which consisted of access aggregation and core layers in the network, are giving way to more of a flatter network design, for instance. For instance, the leaf spine architecture that is more optimized for east-west traffic, for server-to-server traffic, as opposed to north-south. So these changes in the network actually has a direct impact on where the load balancer is placed, first of all, and then do you have opportunities to consolidate? Can you place them in a centralized location so that it's equally accessible from every place in the data center? And then that would directly impact sort of the scaling strategies that you would incorporate as you build out load balancers. So clearly, customers make holistic decisions around their load balancers when they make holistic decisions around both networking applications and load balancers together. And as vendors, we need to keep that in mind and make sure that the load balancers we design and build actually work in different architectures as and when they're emerging in customer environments.
I guess I would also like to talk about scaling up versus scaling out. That's always a big question, right? You've outgrown your first pair of load balancers. What do? Do you buy a larger box, or do you buy multiple? And for us, our solution is we just get multiple. And now the question is, for some people, how are you going to load balance? You can use DNS load balancing, where you just you advertise several IPs for your domain. We actually use BGP. All of our load balancers, we're using LVS with Pieball. This is all open source. You can if you Google Pieball, you can see all of our implementation and download the source code and use it for yourself. And we BGP peer with our routers so that and use our router, BGP's flow hashing to keep consistent sessions. And that works really well and has another major advantage that it tends to be much cheaper than buying a very large box. And you don't have to then throw away your old smaller box.
I agree with that approach. I think there's definitely a new technology arc that's emerging when it comes to application delivery. And I just want to start off saying that there is a difference between application delivery and load balancing. Application delivery is a notion of a platform and services, where load balancing is about spray and pray. Now, when you look at virtualization and really the evolution of what's occurring within network environments, when you start bringing in overlay and other strategies within the data center that allow you to commingle traffic on the same platforms, you start getting into really an interesting time to delivery problem. And although I'm an open source junkie, I also recognize the fact that businesses move faster or need to move faster than what, it takes some time to roll your own. And so whether you have to bring on an army of developers to roll your open source implementation, the question is, how much is it actually going to save you over time? Because as if you go and look on Red Hat's site, free isn't free if you value your time. And time to market, the competitiveness of what's happening definitely makes it a very interesting thing. Now, around scaling, I think there's obviously multiple strategies. I think the most important thing, really fundamental question, at least within the data center, is do you want application delivery services or do you want load balancing services? That inherently is going to directly influence your architecture greater than really a lot of other decisions.
Okay. The second follow-up question that I'll have, and give each of the panelists some time to respond to is, what app services do you expect to be delivered by at this application delivery / load balancing layer, versus what is generally, depending on the environment you're in, I'm thinking of things like, when does it make sense to offload SSL versus handling it? When does it make sense to do connection coalescing at that layer, and other types of different components of delivering a complete service to the user? We'll start from actually, let's start from you this time.
As we think about this question, I think it's important for us to keep in mind that networks and associated network services exist for the applications. They don't really have any other purpose but to make the application run faster, more secure, and more scalable, and ultimately provide a better end user experience. That's the purpose of existence for any of these ADC services, right? Now, when it comes to ADCs have a myriad services. Essentially, TCP multiplexing would actually allow the server to not focus on TCP connection establishment and teardown, but rather focus on what it's meant to do. Sort of focus on the core business logic instead of worrying about a whole bunch of other things like SSL crypto offload or TCP multiplexing or content optimization like caching and compression, and then protecting against security attacks at the web layer, which are deeply embedded logical attacks using web application firewalls and such. So ADCs have advanced functions in terms of content optimizations, server offload, security, and denial of service protection. Huge SYN flood attacks can be easily thwarted by the ADCs, for instance, in millions of SYNs per second of that order, right? So it's really a question of, out of all these services, for your application, as you design your application, what is the subset that you think is appropriate that would allow your application to focus on what it's designed for, and let the ADC offload as much as possible from the application in terms of what I call the overhead around connection processing and even to some extent crypto processing. So.
Well, I'm going to speak specifically about the web. Basically, I find that SSL tends to be the most common thing that people offload onto their load balancers. And most of us here are providing a web service. So you have your normal HTTP versus HTTPS. For the most part, I think it is net positive to remove your SSL decryption from your load balancing layer. Just use your load balancer as a really stupid layer for just forwarding based on TCP. We currently have an Nginx cluster that all it does is the SSL decryption, and it's very efficient at that. The downside is that then you do add some more complexity to your system level. You have to create another cluster of a type of machine, and for some people, they want all of their web servers to be completely identical. And in this case, you obviously, you can have all of your web servers doing SSL decryption based on the number of SSL versus non-SSL. That may wind up having a very inefficient distribution, and so just randomly, some of your web servers may be doing a lot more work than others. And so that can add some complexity, but I think the fact that once again, it comes down to cost. You're spending a lot of money on very fancy load balancers, and the more you do on them, the less connections per second you can run on them.
One thing I wanted to point out is that you touched on the fact that you have an L4 layer and then you have an L7 layer behind that. I mean, that multi-tier approaches are perfectly valid, and I see that a lot. So thanks for bringing that up.
Well, saying, what application services does the LB need to provide? It really depends on the application and the target audience of your application. We actually do have, the nice thing about having 100 plus properties at Yahoo is I get exposed to a lot of different stuff. However, I'm trying to keep the complexity down as much as possible so that I can provide a value-added service for all my customers, not just point-in-time individual solutions for each individual customer. Reality is, though, is I have specific customers inside of Yahoo who have a very serious need for SYN flood protection because they see 4 or 5 SYN floods a week. That definitely influences which box I buy. There are occasionally going to be, some properties who would like us to do SSL offload. But it comes back to kind of what Leslie was saying, that, at some point when you start turning on all the little knobs and whistles and bells, you really do cut into your available capacity. And if you are a high volume capacity driven end user, you need as much as you can out of those boxes because they're not cheap. Going back to the tiered strategy, we play a lot with the L4 at the front, L7 at the back, and that actually does make a large difference on how much more capacity we can deliver. Because obviously, 4 A10 5000s is a lot more expensive than 4 A10 3000s and a couple of servers doing L7.
So this is a whole can of worms right here. So ADCs are like Swiss Army knives, right? So if you need DDoS protection or you need WAF or you need application offload, really think of ADC services as really an extension of your application on the infrastructure. And there's a couple of points here. One of them, if you guys go out on your laptops and go out to VeriSign or Symantec or any of the major SSL vendors, and you say, I want a premium SSL certificate for 100 systems, and you follow their legal agreement that you have with them, you're looking at about $1.5 million out of 100 servers with legitimate SSL certificates on board. So if you turn around and say, all right, well, even just for SSL offload from a business perspective, it starts making sense, right? Especially if you start having lots of capital expenditure around certificates. So let's remove the business side out of the equation of why ADCs actually make sense in these SSL offload environments to get down to the fact that all these services, layer 7 services, really are there to do one thing: mask deficiencies in the application. So the application can be the TCP stack, the application can be the network, the application can be the revenue generator or the cost center that is being written by developers. These developers inherently don't think about security or think about specific functionality in a holistic manner, and as a result, when it comes to deploy, guess what? You have to virtually patch your application. The way you virtually patch them, in our case is through AFLAX or through some specific thing. Look at someone who's doing memcache, and oh wait, I can't do memcache on this server because I'm also doing some other sorts of caching. So how do you fix that when you didn't budget for it? So ADCs are very powerful and can be used as strategic and tactical devices. And ultimately, if applications are well designed, we're kind of out of business. But at the end of the day, we're only out of business if, and I say this, we're only out of business if we choose not to continue to innovate our platforms and provide value, right? And that basically means that we remain load balancers, and which we are not. And we are, if you look at the end game with these services, it's really about providing those additional services that it's good enough, just isn't cutting it.
All right, so we'll move to the next question in the panel, and we'll talk about multi-tenancy. Now, a couple ways to think of the concept of multi-tenancy. Just it's obviously all the platforms we have and available can obviously host as many, more or less as many VIPs as you have capacity for. So you could have multi-tenancy in the sense that you just have different applications, different VIPs running different applications running on the same boxes, and you have to make sure that you don't oversubscribe your system. On the other hand, there are also solutions that provide for a complete administrative partitioning of the hardware or software system, permissions based, where user A can edit his VIPs where user B edits his, and either within a single system or with virtualized images running on a shared hardware infrastructure. So with that framing, I'll start from Mike's end again on this one.
Yeah, so multi-tenancy is kind of a interesting topic. because again, there's three things implied. One of them is that a separation of, you have different data classification or security zones. You have a density problem in most multi-tenant environment. And then you really have to think about the services and really the model of the multi-tenancy. Is it isolated at the OS level? Is it isolated in a virtualized container within a given environment? I think one of the things that the industry as a whole, the ADC industry as a whole has done is actually produce, some pretty good stories around multi-tenancy. Whether it's Citrix with the SDX, whether it's our platform with L3V and our vThunder series, or it's F5 with their vCMP. I think one thing has definitely come out of the industry is that we understand the multi-tenant problem and realize that to some of these points, you do have to commingle traffic to save money. And I think if you look at scaling, unfortunately, we are dealing with finite computing machines. The benefit of our methodologies is that we optimize our code more than let's say a standard install that you would roll. And so the interesting thing is when you start dealing with multi-tenancy, you actually, and you start packing more users into a space and they start consuming more services, you end up dealing with scaling issues at the high end, right? Most scaling problems don't really actually start emerging until you're in the 80% range. And so one of the things I've been seeing is that the fan-out methodologies and really actually looking at where multi-tenancy should actually occur, it's for the most part in the places where you don't have a large aggregation of traffic at this point. So you can have, for instance, I don't want to make this a vendor-specific thing, but we have a WinU platform, 160 gigs, 1,000 partitions on it. That's great. The minute you start throwing all your traffic across it, you may not necessarily achieve it because it is a finite computing machine. With that said, I think multi-tenancy and density are definitely driving factors because, again, Intel's producing the chips, they can only do so much. And as a result, you do have scaling challenges at the high end.
Well, I kind of look at multi-tenancy from an end user perspective, especially if I'm an application owner, maybe using an AWS or whatever. Especially with the advent of the APIs now on some of our application devices. It gives me the opportunity, especially if I'm partitioned off in my own administrative zone, to be able to make API calls to kind of my little load balancer instance, whatever, so that I can gather the necessary stats that maybe AWS or Rackspace doesn't want to expose to me because they ultimately own the hardware. So that's one of the things that is a great value-added service in the LBAS market.
To be honest, it doesn't really apply to us. If we need more partitioning, we just sort of scale out and add another pair of load balancers.
That was a quick pass, so let me, I have a little more time, I guess. So as we think about multi-tenancy is a way to do more with less resources. In a very simplified definition would be that. And it's a way to avoid sprawl. It's a way to avoid sprawl of underutilized ADCs across your data centers. But if you think about what caused the sprawl in the first place, it's actually, going back to an earlier statement, it actually comes back to virtualization being the catalyst that actually allows your data center's application footprint to grow. So as your data center has more and more applications running, it's important that you consolidate your appliances into as small a real estate as possible, and that's the advent for multi-tenancy. However, someone who's doing that also needs to face certain challenges. There are challenges around isolation and administration. Can you manage your devices as though they're your own, dedicated to you, while essentially they're running on shared hardware? That's an important question to address. Do you have the same kind of performance and isolation as you run all these application services on the same hardware? These are, as vendors, we have to invest deeply in technology to make sure that the experience of the end customer who's actually using multi-tenant solutions is not compromised in around, not just in terms of isolation and performance, but also in terms of operationalization. Do you have the right API so that each tenant can control their load balancer as a service independently without impacting another tenant? So operational aspects are very key. And to that extent, actually, networking especially has stood in the way for true multi-tenancy, and especially because networks were built as monolithic structures that are single tenant. That's why we see the emergence of technologies like software-defined networking, where essentially it's completely a centralized control plane, but it offers for multiple tenants to control the network as though they have their own dedicated network, and so follows network services. So from an ADC standpoint, yes, it's a very important aspect, and like Mike pointed out, all the players in the industry have embraced multiple approaches towards solving this problem, which is top of mind for most customers that we speak to.
Okay. So our final discussion topic, I'm going to concentrate on automation, and let's talk about the point at which you have to be. At what point do you have to be automating, and how extensive should does your automation need to be as your app and as your installation begins to scale up? And who wants to start with this one? Let's start.
At what point do you need to be automating? Actually, I think the ones who've actually gone through the process of automating the data centers would have a better perspective. But from a technology vendor standpoint, essentially, I would think that you would want to automate the moment you see yourself doing repetitive tasks more than once or twice. And the need for automation exists, and the advantages to be gained from automation are clear, hopefully, to most operators. The problem, however, is the complexity in automating, and that results from the lack of sort of a uniform API set across different vendors in the same space. Networking does not have a uniform API set. Like security services do not have a uniform API set. ADCs don't have a uniform API set. Each of us have a comprehensive set of APIs that the customer can use to automate, but the same set of APIs cannot be used across different products, and that's a problem. Now, the large vendors obviously have the wherewithal to kind of surmount that problem and actually invest in achieving an automation to the degree where it actually results in operational efficiencies for them. So automation is built into their design from the get-go. However, as you move downstream towards a more broader enterprise, it's hard. The investment needed is actually hard, and it's hard to justify that against the benefits in running your operations, basically. That's changing now, especially because of the advent of standardized orchestration platforms that are actually custom built, not just for the cloud providers, but also for enterprises also. As that changes and it becomes more embraceable by a broader segment, I think we'll actually, all of us would see that more and more data center operations are actually automated moving forward.
So especially for smaller providers, I think that automation, when to automate, can be a bigger deal. If you're Google or Facebook, you can have an entire team that all they're doing is automation. But when it's just me running things, it can be difficult. A lot of times, vendor APIs don't do what they claim. We've all experienced that. So I'm really lucky right now that since we're using a completely Linux-based solution, we're able to use a Linux-based solution to automate it. We're able to use Puppet whenever we have to add in new servers, which makes all of our configuration much more simple. You actually even can see it online if you just Google for Wikimedia operations Puppet, and you can find our repository is on GitHub. So that makes it a lot easier. Of course, if you're dealing with multiple vendors, you have to write an entire abstraction layer. So I would say when you find yourself doing something for more amount of time than it would take for you to automate it, that's when it's time to automate it. Even when you think that you may see yourself doing that in the future, because it does wind up saving you time in the end, even if you delay your your initial deployment a little bit in order to get the automation ready before you start?
I would just like to say that I personally enjoy the concept of copying and pasting bad configuration into network devices. It gives me job security. No, seriously, as soon as you know that you're going to do anything at scale, even if it's not at scale, just you don't want to introduce that human error element. So, obviously for people like in Leslie's boat, it is more of a challenge, but, sometimes maybe you say, we're going to take a month longer to do this correct. And obviously in the OpenStack movement, they're trying to build those abstraction layers originally through Atlas, now through Grizzly. But for the vendors who actually are making APIs available to us, we have people internally who are writing that abstraction layer for us so that we can take our already existing automation tools that are using some more antiquated solutions for pushing configs to load balancers to be able to make it a much faster delivery. And that is actually what you accomplish with automation is a speedier delivery, time to deliver for your end users. So yeah, kind of going back to my original comment, automation is key as soon as you think you're going to offer anything to your end users. And obviously it's been very successful for us.
I would actually really like to second the fact that automation, even if it doesn't necessarily save you a lot of time, the not having to troubleshoot human error will save you a lot of time.
Yeah, I am an automation junkie. I think that automation is actually what all engineering teams should be striving for. If you really look at automation, one of the problems why automation doesn't occur is because the folks that actually understand what they're doing and what mundane tasks they're doing daily, they don't actually know how to go about automating. I think that's one problem. So platforms like Puppet or Chef are actually allowing those teams to actually cut and paste and be able to take configurations they normally would be doing from a CLI perspective and able to automate that. Now, one of the things I do want to say, though, around automation is that, and again, I love OpenStack, and so for those out there who are kind of religious on the OpenStack movement, I apologize. But one of the inherent issues with things like LB as a service, at least historically in Grizzly or even with so basically the Quantum plugin, is that it waters down everything to load balancing, which why are you going to buy a ADC that just does load balancing? It makes no sense, right? Yeah, you can do spray and pray at high volumes and stuff, but for, again, those OpenStack instances or even within a VMware environment or a Zen environment, if you can use open source things to actually take care of the basic load balancing services, it ends up making more sense. Now, when you start talking about things that scale and additional services, remember what I said earlier, you're extending the application onto the infrastructure. And so one of the strategies that we've taken is especially with like Havana, is saying, all right, well, we're going to do the LBAS plugin specifically for us, but we're also creating this framework in conjunction with that, so you can use both, so that you can actually take advantage of our specific services or vendor-specific services, so that if we do offer something that gives you a competitive advantage in market, it's available to you. And I think one thing that ultimately, when it comes down to automation, I really think that every instance of everything should be automated. And what I mean by that is, I don't think automation in my mind is not about actually going out there and saying, I'm going to push this button and something happens, although that is a form of automation. What I believe automation is that the applications themselves are participating in an asynchronous, event-driven environment that allows for orchestration to occur in such a manner that the applications themselves know what they need better than the admins themselves.
I have a follow-up. So I just want to add, basically, today, a lot of the focus of automation is around deploying new application services and associated ADC services. It's around automated provisioning of these services. I think a glaring gap that we are aware of and everybody's aware of is that there is no automated ways of actually retrieving operational status, or especially around troubleshooting and monitoring already deployed services. So that's an area that as vendors we are very well aware of, and it's a key area of focus for us, especially if you integrate into orchestrated environments like OpenStack or vCloud or Cloud Platform or CloudStack, any of these orchestration platforms, you'd see that the operational status and the monitoring aspects, because when something goes wrong, you need quick ways of debugging, and that's a big top of mind item for operators of data centers, right? So automating that and making that as easy as possible for customers is a key criterion for all vendors, I should say.
So before we move on to any audience questions, we have a few minutes, maybe make some final general comments from the panelists. Going once, anyone?
Yeah, so let me just go ahead and just say that, one, it's been a pleasure, and hopefully if my son's going to be watching this on YouTube later, hi to his programming class and everything else. One of the interesting things that I find about ADC is that, you know, if I were to say if any technology was my mother, it would be application delivery. You know, I started my career off as a network jockey, and then got into development work, got into ethical hacking, a little kernel development, a little Apache development. And because of ADC, I've touched every single technology out there. The reason I'm even bringing this up is because if you look at the skills of basically the next generation of operators, you know, kids like my son are coming up, they're going to be well-rounded. They're not going to be single-disciplined. And I think one of the benefits of this is that ultimately those behaviors and the tooling associated with the next gen of infrastructure is going to be driven by automation. And so regardless if it's ADC or whatever technology, the coupling of application state, networking state, server state, and business state, because ultimately it's about the execution of business logic that's at play here, is all going to be bound together by automation. And if you don't have those skills, by the way, in the future, then you're probably going to be left out in the dark because technology is changing quick.
I would like to say, especially on automation, that right now it is sort of more in its infancy. And, you know, as network engineers, we all love to cut and paste and reuse solutions because it's way easier than doing your own. There aren't a lot right now, especially for the commercial platforms. But if anyone is writing these things, I would highly encourage you to open source it so that all of us in the community can then be lazy and use your tool.
I just want to say I'm glad that we are in interesting times. This is a time of change, and we can actually see the change in so many directions. Storage gets centralized, applications get disaggregated, networks get virtualized, data centers get multi-tenant, everything is software-driven, hardware gives way to software. There are so many trends in the data center. It's very exciting to be part of this journey. There was a time when it was all about speeds and feeds and features and functions. Now it's more about elasticity, expandability, agility, multi-tenancy. The metrics to evaluate data center operations have changed, and they've changed in a good way. And I'm excited to be part of this journey.
So for me, just kind of follow up, I really enjoyed the whole application delivery component of my career because it's one of the few things that really force you to have a holistic view of the internet as a whole, and B, just of the application stack. I've spent most of my career in some larger shops, and I definitely see a lot of siloing that goes on, you know, whether you're a web hosting provider or whatever. You know, just across the realm. This gives you the one opportunity to shine across multiple realms and not just get pigeonholed into one little, you know, one little small niche.
Okay, so thanks everyone. And it looks like we've got about 11 minutes left for any audience questions. You in the center, you are up first. Go ahead.
Jared Manzer from GoDaddy. I'm a Ruby and Perl coder, and I've been doing network automation for quite some time now. And aside from firewalls, switches, and routers, we also automate for load balancers. And one of the problems we found is that when it comes to accessing the configuration items on load balancers, SNMP is not a very good way to go. we since trained our software to behave like a human and log into the SSH prompt and pull data there, but really there's a lack of consistency in being able to programmatically extract data from the various load balancing vendors. And that's been a bugbear for us. So what's happening in the industry to standardize that kind of data extraction to make it easier for us to actually focus on workflows and not hammering out the idiosyncrasies of your dialects and your platforms?
Yeah, so that's actually a really cool question. You know, I have the opportunity of working for like the top three ADC vendors in the market, and I've seen the evolution of ADC over time to where, you know, if you look at, Nitro API, if you look at the iControl API, or you look at our API, they all have different flavors. I think one of the things that's happening right now is that there's a better understanding, at least from a vendor perspective, of how things should be laid out, right? And I think projects like OpenStack and other purist type projects are actually, we're able to extract lessons and methodologies from those projects. So I think being able to make sure that you have again, a good Rust implementation around being able to have basically a object and then an identifier, then an object and an identifier, and being able to query and pull URLs that may give you actual endpoint resolution that you can, again, recurse through. I think those are some of the trends that are happening, and I think most of the vendors are actually embracing that because it just makes sense. That's what's going to integrate into other third-party environments, and I think having to rewrite code or at least create a new framework or methodology to highlight our own benefits is actually a ridiculous notion. So to your point, there has been a lot of frustration. I think the industry as a whole is changing now.
I just want to add one more point to that. Totally right that there have been API sets per vendor which are more or less comprehensive. Everything you want to automate for a given vendor, you would probably find APIs for that vendor. What doesn't exist is actually a vendor agnostic set of APIs that you can actually consume without worrying about the underlying platform where those APIs are actually exercised. And clearly the most important thing is that the industry recognizes the need for it, and that change is happening with OpenStack or CloudStack or vCloud or any of these cloud orchestration platforms. Each of them is focused around building an ecosystem that offers a common API set to the tenants or to the user, basically. The harder problem is the functions of an ADC especially are so vast, and there's so much you can do with that it's a matter of priority and a roadmap as to what we can automate first, and then standardize automation for first, and build a roadmap for one of these cloud orchestration platforms. OpenStack, for instance, today is focused on basic load balancing functions. It hasn't reached a point where you can deploy advanced LB functions or advanced ADC services through a common set of APIs. But that's the general direction. And as vendors, it's in our best interest to actually accelerate that movement and make those services available to the user as soon as possible.
So we're actually going through a similar transition to you. We ultimately have had to end up writing our own abstraction layer, finding commonality so that my end users can figure out yay from nay, but then ultimately writing our own subroutines to support what A10 versus Citrix may or may not do in the perspective of how it gets pushed to the config. But yeah, we've been doing something similar with the SSH expect method as well for the last few years, and it's very slow and arduous and prone to error as well.
Yeah, I'll jump in myself on this one because I actually feel a lot of the same pain. In my environment, I got lucky because I have a multi-vendor environment, but the two vendors I started with had very similar models, configuration models, and that worked to my benefit and made our first round of automation tasks a lot easier than by all rights it should have been. Of course, that ended when we tried to expand the vendor breadth. So yeah, I know the pain of which you speak. So we have another question on my left.
Yeah. This is Adi from the University of Michigan. So we use load balancers extensively for HTTP primarily. And I think that's because the the clients and the servers in HTTP have a fundamental problem which ADCs try to fix, and they could be fixed much more easily if DNS SRV support was added to browsers. Now, every one of the popular browsers has open bugs on adding SRV support, and in some cases they're over 10 years old. And if I were a conspiracy theorist, I would think that the ADC manufacturers are paying so those bugs don't get fixed.
Yeah, there's totally a conspiracy, man.
Yeah, I knew it.
Yeah, we have a lot of things that we do, and that's definitely one of them. Whole
Small
Black
bit-
Ops movement.
Small bills and briefcases. Yeah, they're passing them right behind me as I speak.
So as much as I would like to indulge that fantasy, unfortunately, that's not the case, right? If you look at ADCs and one of the benefits beyond just that it actually really comes back down to optimizing the bandwidth delay products in between the client and servers, right? So when you start talking about things like full TCP proxies and all that, there's additional benefits that can actually help optimize the client-server relationship. With that said, I don't think that there's actually an industry-wide conspiracy. I think it's just the fact that most people are lazy and it's not important, and
So I wasn't suggesting
I know.
that there was
I'm just giving you a hard time.
a conspiracy. Yeah, but for most cases, you don't need all the, for most customers, for most industries, you probably don't need all the ADC bells and whistles. And in our case, the load balancers for failover and availability, not really for bandwidth or latency, because we're a very localized ISP, and the 100,000 people who use it are within 5 square miles. So it's not, we're forced to pay for features we don't need, and we're forced to pay for hardware we wouldn't need if there was DNS SRV support. And so, what my plea to the people in this room would be to just go to your favorite web browser site, and ask for that bug, vote up that bug to be fixed. It's easy fix. It can be done in the client, and it serves most sites.
I would like to warn, though, against solely using DNS for a load balancing purpose, because it's...
I wasn't saying solely.
Oh, okay.
Clearly, hybrid approaches are okay too, but the point is the low-hanging fruit of SRV records. And SRV works for lots of real-time applications really well. So there's no technical reason it couldn't work for HTTP or HTTPS.
Other than DNS has no notion of state.
And that's what SRV records address, right? The
Yeah.
client decides the notion of state, and that's really what you care about, is whether the client can get to the server or not. The client should be the ultimate arbiter of state.
Yeah, and so if you look at that initial DNS request and to identify whether or not a service is available, that actually delays the first byte of the application getting to the end user. So ultimately,
You always have a DNS lookup.
yeah, but if the service isn't available, right?
No, you still have the DNS lookup, and the
Absolutely.
client decides, right? With SRVs, the client decides which one is reachable, and you can weight them. So it works for SIP, it works for LDAP, it works for Kerberos. It works for lots of other TCP and UDP services really well. There's no reason why it couldn't work for HTTP and HTTPS.
The one of the things for, assuming it's a public-facing application, for a lot of DOSes are actually fairly low in number and pretty stupid, honestly. And but it's a lot easier for them to actually have a successful attack if each of your application servers has its own IP, and then it can partially deny service by having 1/10 of your servers be offline. Whereas if you have a load balancer, it spreads out the wimpy attacks via a lot of machines where you won't even notice it.
The SRV records can have many, many machines in them, right? The load balancer is a scaling bottleneck, right? So yeah, you can prevent DDoS with this, or you can mitigate the effects of a DDoS with your load balancer, but you have to size it appropriately to do that. So it's where you spend your money. So 99% of the time, the SRV record will work fine. Yeah, you're in maybe the top 25 web properties, you need ADCs behind the SRV record. That's fine. But if we fix the basic protocol and the clients, then, I'm sorry, but we'll have to take your business away from all the ADC manufacturers, and you should be okay with that.
All right, thank you. One more question in the middle.
Thanks, Chris. Anton Capello, 5 Nines. It seems to me that there's this overloading effect of like controlling or wanting to concern ourselves with the rendezvous protocols, like the SRV, DNS kind of things, as a ramp up to getting data exchanged. And part of that result then is we have this complicated layering and complicated interrelationship. As you all certainly are aware, multipath TCP is now in iOS 7. Citrix NetScaler has supported the termination of this for some time now. It seems like we're getting to the point where maybe layer 4 stuff, as a result of whatever rendezvous we're using, DNS, MDNS, maybe discovery through some sort of bootstrapping AJAX API, whatever it is, the client's going to talk to something on layer 3. The session's what you're talking about here, principally in distributing this load, right? So I'm curious, Citrix has implemented support for terminating this. It seems like it's interesting, perhaps, for some number of you to consider something like that as a way to provide indirection, the level that we want, to some level that we need, rather, for the purposes of load balancing. So I guess to the question here, if Citrix can already terminate this stuff on one box, what's stopping us from having the session land on multiple machines that can also share the state, such that we affect load balancing, and the client can benefit by using multiple paths that it might have, say Wi-Fi, say cellular, and perhaps reduce the state just to the level of TCP. Is there anything happening besides what Citrix is doing, or is this interesting to anybody up in the panel here today?
So there's lots of strategies around this specific topic, right? If you look at really multi-device load balancing or being able to cluster services across, really ultimately comes back down to efficiency, right? If I have to constantly be sharing state, and let's say I am, greater than, let me give you an example. If ADC 1 and ADC 2 or service 1 or service 2 is, let's say, 100 milliseconds away, the client is 20 milliseconds away, can you really share state across those services and actually have that data, that information actually relevant? So really, these are time-based problems that when you start getting in proximity to one host to another, a lot of these things fall down, right? So with that said, I think that there's actually room for improvement for TCP, actually. And I think there's room for improvement for a lot of different areas. But actually, hit me up afterwards. I'd like to get your thoughts on that. We're out of time, though.
Thank you.
All right. So that's our time. Thanks everybody for listening. Thanks to the panelists for speaking with me. And we'll see you next NANOG. Thanks.